Welcome to the class. In our previous video, we have learned how to find the inverse of a square matrix using adjoint of it. In this video, we'll learn how to solve a system of linear equation using inverse of a matrix. So let's start. Let us consider the system of equations a1x plus b1y plus c1z equal to d1, a2x plus b2y plus c2z equal to d2, a3x plus b3y plus c3z equal to d3. Let the coefficient matrix be A is equal to a1 b1 c1, a2 b2 c2, a3 b3 c3 and a3 b3 c3. The variable matrix x is equal to x, y, z and b is equal to d1, d2, d3. Then ax is equal to b, a1 b1 c1, a2 b2 c2, a3 b3 c3 into x, y, z equal to d1, d2, d3. When A is a non-singular matrix, that is, determinant of A is not equal to 0, Ax is equal to B, pre-multiplying both sides by A inverse of Ax equal to A inverse B, Ix is equal to A inverse B. I is the identity matrix of the same order as A, so x equal to A inverse B. This matrix equation provides the solution of this system of equation as A inverse is unique. So the product on the right side will be unique. Hence the solution will be unique. Case second, when determinant of A is equal to 0, in that case we'll calculate adjoint A into B. If adjoint A into B is not equal to 0, then the system has no solution. That is, the system is inconsistent. When we have two equations in two variables, this situation is equivalent to two parallel lines. It means that they are not meeting anywhere. And when we have three linear equations in three variables, this situation is equivalent to a case where at least two planes are parallel. Means all the three planes are not intersecting at a single point. Means they don't share a common corner. Now when adjoint A into B is equal to 0, then the system will have infinitely many solutions. That is, when we have two equations in two variables, this situation is equivalent to two coincident lines. And when we have three equations in three variables, this situation is same as we have three different equations for the same plane. It means that we are representing same plane using three different equations. Now let us discuss consistency and inconsistency of a system of equations. If a system has a unique solution or many solutions, that is determinant of A is not equal to 0 and determinant of A is equal to 0 and adjoint A into B is also equal to 0, the system is called consistent. That is, if a system has unique solution or many solutions, we can say the system is consistent, otherwise it is inconsistent. When determinant of A is 0 and adjoint of A into B is not equal to 0, in this case the system has no solution. It means that system is inconsistent. Now let us solve some problem from the textbook. Question number 1. Examine the consistency of the system of equations in exercise 1 to 6. So let us take the first equation. X plus 2y is equal to 2 and 2x plus 3y equal to 3. So here the coefficient matrix will be 1, 2, 2, 3. Determinant of A is equal to 1 into 3 minus 2 into 2 equal to 3 minus 4 equal to minus 1. Here determinant of A is not equal to 0. It means that the system has unique solution. It means that this system is consistent. Now let's see question 3. X plus 3y equal to 5, 2x plus 6y equal to 8. Here coefficient matrix A is equal to 1, 3, 2, 6. Determinant of A is equal to 1 into 6 minus 2 into 3 is equal to 6 minus 6 is equal to 0. Here determinant A is equal to 0. So we'll calculate adjoint A. We know that the shortcut method of finding adjoint will interchange 1 and 6 and will put minus sign against 2 and minus 3. So the adjoint will be equal to 6 minus 3 minus 2, 1. Now we'll find adjoint A into B equal to 6 minus 3 minus 2, 1 into 5, 8. So let us find the product. 6 into 5 minus 3 into 8 minus 2 into 5 plus 1 into 8, 30 minus 24 minus 10 plus 8. It will be equal to 6 minus 2. So clearly this is not a null matrix. So adjoint A into B is not equal to 0 and determinant of A is 0. It means that this system has no solution. It means that this system is inconsistent. Now let us solve question number 15. Question number 15 says if A is equal to 2 minus 3 5 2 3 minus 4 1 1 minus 2, find A inverse. Using A inverse, solve the system of equations. 2x minus 3y plus 5z equal to 11, 3x plus 2y minus 4z equal to minus 5, x plus y minus 2z equal to minus 3. Now if you observe carefully, you will see that matrix A is exactly same as the coefficient matrix of this system of given equations. So we'll find A inverse and that inverse will use in solving the given equation. Let us find determinant of A. Determinant of A is equal to 2 into 2 minus 4 1 minus 2, 3 into 3 minus 4 1 minus 2 plus 5 into 3 2 1 1. So it will be equal to 2 minus 4 plus 1 plus 3 into minus 6 plus 4 plus 5 into 3 into plus 5, 3 minus 2, 0 plus 3 into minus 2 plus 5 into 1 minus 6 plus 5. Determinant of A equal to minus 1. It means that A is a non-singular matrix. It means that we can find its inverse. So for the sake of convenience, let us write matrix A once again here, so that we need not to scroll the page again and again. So A11, A12, A13 we have already calculated. A11 equal to 0, A12 equal to 2, A13 equal to 1. So A12 is equal to minus A12. A12 means 1 plus 3 odd number, so minus sign. 6 minus 5. A22 is equal to minus 4 minus 5. A23, as 2 plus 3 is odd number, minus 2 plus 3. A31 is 12 minus 1. A31 is 12 minus 10. A32 is minus 8 minus 15. A33 is 4 plus 9. So coefficient matrix will be equal to 0 to 1, minus 1 minus 9 5, 2 23 13. So adjoint A will be the transpose of this cofactor matrix. So adjoint A is equal to, rows will become columns and columns will become rows. 0 minus 1 2, 2 minus 10 23, 1 minus 5 13. So A inverse equal to 1 upon determinant A into adjoint A. So determinant A is minus 1. As minus 1 will distribute each and every element of the matrix. So A inverse will be equal to 0, 1, minus 2, minus 2, 9, 23, minus 23, minus 1, 5, minus 13. Now B is equal to 11 minus 5 minus 3 and X equal to A inverse B. A inverse is 0, 1, minus 2, minus 2, 9, minus 23, minus 1, 5, minus 13 multiplied by 11 minus 5 minus 3. So let us multiply it. 0 into 11, 0, 1 into minus 5, minus 5, 2 into minus 3 is plus 6, minus 2 into 11 minus 22, 9 into minus 5, 45, minus 23 into minus 3 is 69, minus 1 into 11 minus 11, 5 into minus 5 minus 25, minus 13 into minus 3, 39. So the sum will be 0 minus 5 plus 6, 1, minus 22 minus 45 plus 69, 67 minus plus 69, 2, minus 11 minus 25 plus 39, minus 36 plus 39 is 3. So x, y, z equal to 1, 2, 3. So x is equal to 1, y is equal to 2 and z is equal to 3. So this is the solution of this equation. So this much only in this video. In our next video, we'll discuss continuity and differentiability. Until then, keep learning. Thank you.